So here, looking at the problem, a shipping company requires that the sum of the length plus girth of a rectangular box must not exceed 180 inches. Find the dimensions of the box with maximum volume that meets this condition. The girth is the perimeter of the small space of the box. So the constraint, we have x is length, and then girth, which is the perimeter, 2y plus 2z equals 108 inches, and the function is volume is x times y times z. So next we want to take the partial derivatives for the constraint and the function. So the partial derivative of the constraint in terms of x is 1, in terms of y is 2, in terms of z is 2. For the function in terms of x is yz, in terms of y is xz, and in terms of z is xy. And then we want to use the Lagrange function, which partial of x, function partial of x equals lambda g function partial of x. Same thing for y, function partial of y equals lambda times g partial of y, and function of z equals lambda g partial of z. So next here, when we put them together, for the x portion we get yz equals lambda times 1. For the y portion, xz equals 2 lambda, and for the z portion, xy equals 2 lambda. So if we multiply the first function by x, the second function by y, the third function by z, so we can substitute. We would substitute, if we do these two first, we get x lambda equals 2y lambda, dividing by lambda on both sides, we get x equals 2y. And if we put these two together, we notice that 2y lambda equals 2z lambda, we divide by 2 lambda, and we get y equals z. So then when we plug these back into the original, we would do, if we put it all in terms of y, we get 2y plus 2y plus 2y equals 108. So that's 6y equals 108 inches. Divide by 6, we get y equals 18. So going back up here, where x equals 2y, we know that the length is 9 inches, the width is 18 inches, and the depth is 18 inches. So our max volume would be 9 times 18 times 18, which is 2,916 inches cubed.